According to the Oxford Dictionary, triboelectricity is defined as the electric charge generated by friction. Friction is defined as the resistance that one surface or object encounters when moving over another in the Oxford Dictionary. When two different materials come in frictional contact, they transfer charges and become electrically charged. When a positively charged and a negatively charged material are brought in physical contact, they would equalize the charges between them, causing a flow of charges, which is what we know as electricity. The amount of charge flow depends on the materials that come in contact. In the Triboelectric series published by John Carmichael in 1757, materials can be seen arranged from most positively charged to least positively charged. This is a simplified triboelectric series. For example, if human hair and Teflon comes into frictional contact, it will cause a greater charge flow than if human hair comes into contact with silicon.
Triboelectricity can be found everywhere when there is friction, from combing your hair to something frightening like lightning.
Let's try rubbing hair with a balloon. What would you observe? You will observe that the hair sticks to the balloon.
This is because when the balloon rubs on the hair, charges in the hair loses electrons to become positively charged. It then gets attracted to the charge of the balloon due to the balloon gaining electrons from the hair to obtain a negative charge. This occurrence demonstrates Coulomb's law, which states that positive and negative charges attract, and to the triboelectric series, which is a list of materials that states which materials are more positively or negatively charged.
Researchers at Georgia Institute of Technology envision triboelectricity to power mobile devices and sensors by capturing wasted mechanical energy from sources like walking, the wind blowing, ocean waves, and even car driving by. The team built a prototype generator using sheets of dissimilar materials, an electron donor and an electron acceptor, which allows electrons to flow between them back and forth, generating AC power. The first application will likely be sensors with no conventional power source. The sensors will be used to measure sudden movements, changing in flow rates, and even falling raindrops.
When an aircraft is flying in the sky, it is bound to fly through clouds. When the aircraft is flying through clouds, the clouds could be negatively charged. The aircraft will pick up on those charges due to the friction between the aircraft and the clouds. The charges will then accumulate on the skin of the aircraft. After the charges accumulate, the charges will try to discharge through sharp edges like the communication and navigation antennas, which transmit and receive radio waves. The accumulation of charges on the antennas could cause interference that reduces the effectiveness of communication or block the reception entirely, which could be a serious problem for the aircraft. To combat this, static discharges or static wicks are introduced on prominent sharp edges on the aircraft, such as the ailerons, the elevators, and rudders. These static wicks allow a more conductive path for the electrons to leak back into the atmosphere. This will prevent charges to build up on the communication and navigation antennas.